Um, there is a this is a washing machine, water pump. So you can see, let me check. It's a drain pump using a washing machine. So when we talk about it, is a 220 to 230, 240 volts, 3000 RPM. You can see it written over here, 2000 RPM. So see it is written over there. So meant for to pump water, washing machine. So there is an interesting. It is a motor, AC motor. There's an interesting things I found about the motor. So likewise this one. So but I just damaged this one too. Use it as experiment. So let me open it. Let me open this one. Yeah. The way they design it. I see this is the coil. This is the iron core. So it bring these two coils together. See it. And here is the magnet. See it. Here is the magnet. Is a ceramic magnet. See. So I don't know how many poles that is here. Either two or three. Three pole. So I will go straight to the point. There is a, what I found interesting thing I find about this motor. There is a lot of magnetic flows flowing over here. There is a lot of magnetic flows flowing over here. So which I'm going to connect it to this socket so that it, you see how the motor run and the interesting thing I'm trying to bring out about the motor. I'm going to connect it to the power source now. So let me connect it to the power source. See, the motor is rotating. So now let me uh, uh, go straight to what I want to demonstrate. You can see, over here, it captured the magnet. So when the motor stop running, the it fall. But once the motor is running, so let me remove it from power source. You can see, you can hear the sound. You can see. So now, what I find about interesting about this motor is that you can see there is a magnetic force. It acts like a magnet. You see, you can hold a magnet. Let me remove it from power source. It has fall. So which means there is a extra power going on. There is extra power going on it, or maybe you can extract some amount of power from the motor and see how it runs silently. So let's know if there is a some magnetic flux around it. So this is some wind coil. So I'm going to connect it to this meter to know to read the voltage around it. So it has already started gathering some amount of, you can see, 7 volts, 9 volt, 10 volts, 13 volts. It is not physically touching the motor. You can see it, the distance. So you can see the distance. Let me put it on top. So we generate about 19 volts, 20, okay, 17 volt now, 18 volts is fluctuating, 20 volts. Let me put it by the side. But the same thing, 17 volts, 17 volts. Oh, let me remove it from the source. There's no any. So which means that while this motor is um doing its work, like using it to pump, that we can extract some amount of energy from the source due to uh the way they structure it, the way they structure the armature, the way they structure the motor. It has the exposed magnetism flaws, so which it can, there is some amount of energy that can be extracted. You can see, you see the way they design it. So there's some leakage of flaws. There is amount of energy that can be extracted from this area while the motor is spinning. And the interesting thing again is that when you are loading from here, it doesn't in any way interfere in the motor power, like reducing the speed of the motor. It doesn't in any way uh, affect the motor in any way. So which means that it is partially or totally independent when you are extracting power. So far you didn't attach it inside. You are extracting it from the outside. It doesn't in any way affect the motor. Okay, let's okay, it has, let me put it again. So I'm going to wind a special coil and see, just bring in the coil, and someone can have this coil multiple, maybe around three. Put this one at the side by side, putting one by side, then maybe put two at the top. It can extract some amount of voltage without affecting the input. So without affecting the input, you can see some amount of voltage will generate. I don't want to put any load because the voltage is not stable, and two, the power source I have here is 12 volts. So which means if I bring it close, it can, the voltage might rise. So which will get it burn. So you can see. Oh my God, what am I? I got up to 61 volts. Unbelievable. I got up to I got up to 60. The reading is from the AC. Let me switch it to the highest voltage. 56 volts. So which means if I put any DC, it will get it damaged. So okay, I bring it so close to the iron core. Okay, let's watch what's happening. Okay, let's see. 50, almost 60 volts AC. 50 volt AC. It's sliding away. the voltage shifting, sliding away, the voltage is reducing. Wow. So let me leave it some distance. 1 volt, 2 volts. Let me bring it so close. Then 10 volts. Let me bring so that it will be physically touching the stator, the core. It's now physically touching it. So 69, 69 volts AC. That's what I generated. You can see. So which means if I have this coil by two, so I will generate up to 110 volts, whereby pressing the coil this side and pressing the other coil this side, I will generate a huge amount of volts. Okay, let me just check it from the coil. So, see, position it this way, then position the. I got up to 70 volt now. Okay, 70 volts. That is interesting. You see the where I positioned the coil. 70 volts. Wow. I wish I get I'm with a AC bulb here, maybe 5 watts or 10 watts. I will connect it to see how it will perform. So can you imagine 60, 62 volts? When I bring it so close now, because you can see there is a little gap here. So let me bring it so close. Okay, 70 volts, 72 volts. See? Wow, that is a interesting thing. That's interesting. So there is a lot of things to observe here. There's a lot of things to observe, which means can extract energy from this motor due to expose magnetic field, uh, and extract energy. Because let me bring okay, let me bring magnet here. Let's see how the magnet will dance. Permanent magnet. Let's see how it will dance. Okay, you can see the magnet is dancing. So you can see how it's dancing, vibrating in my hand. The vibration is too much. You can see there's a lot of. You can see how the magnet is dancing in my hand. You see how the magnet is dancing in my hand. So there is a lot to check and observe from this experiment. I generate up to 70 volts. So which means if I have two coil of this, I will I will have times two of the voltage. I will have times two of the voltage. I see. If I have two of this coil, I may have up to 140 volt or 150 volt AC. So which I will use it to generate, ready to power some bulb. And the main thing I observed from this is that it doesn't has any direct effect or drawing more input from the coil or from the motor, drawing more input, more current from the source. This is like just a wasted magnetic flux, just like a wasted magnetic flux. Which we can correct it, we can extract it to power some load without uh, affecting or drawing uh, more uh, more power from the source. So this is a very interesting. Now we still dig more on it. We still do more experiments regarding this thing. So you can see it's on AC. It's on meter is on AC reading. So high voltage 64 volts. When I use my hand to bring it so close, you can see a gap. Let me bring it now close. Bring it close. Okay, you can see reading 70. You can see 74. Okay, that is it for today. Okay, let me check it from the back. No, it is not concentrated at the back. There's nothing. I got almost nothing. Okay, 6 volts from the back, but from the side by side, that's where the magnetic force is concentrated. Let me see. Okay, so thank you for watching.